Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem, next module. Problem number 9, fluid mechanics. As usual, we first come towards its statement. Okay. Find the pressure increase in the fluid in a syringe when a nurse applies a force of 42 Newton to the syringe's circular piston, which has a radius of 1.1 centimeter. Okay, what we have to find out? We have to find out pressure increase. Radius is given in centimeter, we will have to convert it in meter. Okay, so we start it as usual in our previous modules. Okay, from the starting with the definition of pressure. Okay, solution. We know that the pressure P in a fluid is the force per unit area exerted by the fluid on a surface. Pressure is defined as force over area. Okay, these three lines are read as is defined as or is equivalent to. Okay, in place of three lines we can also simply write a sign of equality. Okay, in the SI system, pressure has units of newtons per square meter, that is capital N over small m square, Newton per square meter, and 1 Newton per meter square is equal to 1 Pascal, denoted by Pa. Okay, dear students, here because as we have to find the pressure increase. Okay, pressure increase means change in pressure. Okay, so where change is involved, we can also use the symbol delta. Okay, so in place of simple P, we can also write it as delta P. Dear students, delta and del operator. Okay, del operator, which is usually used in vector analysis, del operator and delta are written in approximately inverted form. Okay, so here in place of P we can also write it as delta P, because delta stands for change. Okay, anyhow, using F equal to 42 Newton, this is given in this statement. Okay, 42 Newton. Okay, A equal to pi r square. Dear students, formula for calculation of area differs according to different geometrical shapes. Here circle is involved. Okay, this range is a circular piston. Okay, so area of a circle is pi r square, while area of a sphere is 4 pi r square. Similarly, a formula for area for different geometrical shapes differs. Okay, so here, because while calculating area pi is involved, so we should also fix its value. Pi, that is 22 by 7, is equal to 3.17. We have previously mentioned many times that decimal representation of pi is non-repeating, non-terminating, it goes endlessly. Okay. Radius r is given as 1.1 centimeter, but because we are following MKS system, we have to convert it in meter, so it will become 0.011 meter. Okay, centi means 100, meaning 100th part of a meter. So when we convert centimeter into meter, we have to divide by 100. On the other side, when we have to convert meter into centimeter, we have to multiply with 100. Okay. So putting all these values in equation number 1, this equation, and beside this, using this definition of Pascal, equivalent definition, that is 1 Pascal is equal to 1 Newton over meter square, as we have previously mentioned. In the SI system, pressure has units of newtons per square meter, and 1 Newton per meter square is equal to 1 Pascal. Okay, so 1 Pascal is equal to 1 Newton over meter square. 1 Pascal is equal to 1 Newton over meter square. So if we use the value of Newton, then it takes the form as 1 Pascal is equal to 1 kg over meter second square. And in another alternate form, it can also be written as 1 Pascal is equal to 1 joule per meter cube. Okay, we have nothing to do with this last equivalent value. Okay, we are concerned only with these two equivalent values of Pascal. Okay, so putting these values in equation 1, we get pressure equal to 42 Newton divided by 3.14 into value of R, which we have converted from centimeter into meter whole square. Okay. Okay, P is equal to F over A, F is equal to 42 Newton, and A is equal to pi R square, pi is 3.14 and R is 0.011 meter cube. Okay, this will alternatively become equal to 10543.77 Newton over meter square. Okay, what we have done, we have simply we have just simplified this expression, and then what we have done, we have simply converted Newton over meter square into Pascal. Okay, because 1 Pascal is equal to 1 Newton over meter square. Moreover, here we have also shown 1 Pascal is equal to Newton over meter square. So Newton over meter square, in place of Newton over meter square, we have used Pascal. Okay, so this value can also be written as 1.1 into 10 raised to the power 5 Pascal. Okay, dear students, if we write it as 11054.377, then it will become into 10 raised to the power 1. If we write it as 1105.4377, then it will be multiplied with 10 raised to the power 2. When we write it as 110.54377, then it will be multiplied with 10 raised to the power 3. When we write it as 11.054377, then it will be multiplied with 10 raised to the power 5. And finally, if we write it as 1.105437, then it will be multiplied with 10 raised to the power 5 Pascal. Okay, so these are just alternate values of writing this expression. Okay, and this is approximately equal to 1 atmosphere. Okay, within bracket, because 1 atmosphere is equal to 1.013 into 10 raised to the power 5 Pascal equal to 101.3 kilopascal. Okay, because here, dear students, kilo means 10 raised to the power 3. If we convert it into 10 raised to the power 3, then 2 power will be multiplied with this and it will become 101.3. Okay, and in place of 10 raised to the power 3, k will become, okay, because kilo means 1000. Okay, because 1 atmosphere ATM is equal to 1.013 into 10 raised to the power 5 Pascal equal to 101.3 kilopascal. Similarly, dear students, we can write it as 0.1013 megapascal. Okay, it is our discretion to write it in different forms. Now we will consult a table in which it will be given that 1 atmosphere ATM is equal to this. Okay, this is the table. Conversion factors between different units of pressure. Okay, 1 ATM is equal to 1.013 into 10 raised to the power 5 Newton per meter square. Alternatively equal to same value up to this and in place of Newton per meter square Pascal, and then 101.3 kilopascal. Okay, here because 10 raised to the power 3 will be converted into k and 10 raised to the power 2 will convert this into 101. Okay, so this is the end of our module. However, in the last we will give a reference from where we have chosen this problem. Reference book is Fundamentals of Physics Extended, Holiday and Resnick, Journal Walker. Publisher is Wiley. Its 10th edition 2014 or 11th edition 2018 will be is being followed, is being adopted. Okay, here chapter number 14 under title Fluids is our concerned chapter, and this problem is enumerated at serial number 3 of the exercise of this chapter. Okay, that is module number 3 of the exercise of this chapter, that is exercise number 14.3, and this is the end of our module. Okay.